Okay, this video recording will be covering the vector functions and space curves, just an introduction. Okay? So vector function and space curve intro. This is just the part 1. So I will write a vector valued function is a function where the domain is a set of real number and whose output is a set of vectors. Okay, we can write the expression as R so this is our T, meaning this is our input or our domain here. Okay, and this tree is function f, g, and h, which is our component function. Okay. If I have my R is cosine t, if I have this kind of functions, let me write the t and maybe and some set of t from 0 and then pi over 2. Let's just take the t as easy value for the trigonometry, cosine and sine. So let's just take pi over 2 pi and 3 over 2 pi. And then our set of functions will be 0, cosine 0 is 1, sine 0, 0, okay. And then pi over 2, cosine pi over 2 is 0, 1, pi over 2, and then pi is negative 1, 0, pi. Then 3 over 2 will be 0, negative 1, and 3 over 2 pi. If we try to draw our vector functions, we can do that. So we draw the Cartesians x, y, z, and then we start with the 0, t equals 0. So 1, 0, 0. Okay, so 1, 0, 0, maybe 1 is here. Okay, and I will write this as t equals 0, and this is our vector. Okay, and then when t is equal p over 2, we'll start from x is 0, y is 1, maybe here 1 is here 1, but the z is p over 2, maybe going up a little bit, going higher a little bit. Okay. So here is t equal pi over 2, and then when let me draw the negative part here. And when t equal pi, x is negative 1. Negative 1 is here, and the back side of this line. Negative 1, 0, pi. So here, and then if this is pi over 2, this is pi, so it will be here. Okay, and this is our t equal pi, and then 3 over 2 pi is 0, -1, and 3 over 2 pi. So y is here, so maybe -1 is here, so -1, -1, and then 0, x is 0, y is -1, maybe here is 3t. So this is my t equal 3 over 2 pi. So my curve, or my space curve, okay, we will go for the definition later. It will start from this end point here, all this blue dot here, the blue. So we connect all. Okay, it seems we are getting somewhere here, but let me just get back to the definition first. Okay. So official definition, okay, of a vector function. Okay, consider vector function and then the set curve of all points from x, y, z such that x is function of t, y is function of g, and z is a function of h, is called the space curve. And t is called parameter. Okay, I hope you still remember, okay, from previous parametric equations and factors. So if we need to plot this space curve by the function cosine t, sine t, and t, the same as previous, but we will set the t as 0 until 2 pi. So this is our starting point and this is our end point. Okay, so let's just draw similar to our previous graph. It's x, y, z. So from before we get like this, right? So if you imagine the sine and cosine, okay, let me draw for you in here. We will have, for cosine you will get like that, right? And for sine you will get, right? You get the red is sine x, the blue one is the cos x. Okay, remember? So if you are going to continue this blue dot here, it will define, or it will create a helix. Okay? So if you start here, this is t equals 0, will go yeah, more or less it's like helix. Okay? Like if you combine the sine and cos, okay, and you have a circle, right? Sine and cos. So it will be like this. But because you are changing the level of z, so as the circle going higher, it will be a helix. But if you see from one side, okay, to the projections, it will be a circle. So this helix will be a circle. So we need to just mention the starting point. This is t equals 0, and this is the starting point, and t equal 2 pi is the end point. So t is t equal 2 pi is the same as or similar with the t equals 0, where the cos is 1, sine is 0, but the z level is 2 pi. So t equals 0, t equal pi over 2, pi, 3 over 2 pi, maybe around here. So this is my space curve, and we gave the curve an arrow to show that it's moving from t equals 0 until t equals 2 pi. Okay. I hope you understand what the graph really means. Okay. Let me give you just examples to sketch how to sketch the vector function, or the idea at least. Okay. So first you have functions, okay, and you have only these functions, for example. So this is your x, this is your y, but there is no z. Okay, so we will deal only in xy plane or 2D sketch, right? So we start by saying that the x is sine t and y is t. So when t is 0, okay, x is 0, y is 0, right? And then if you see this t, okay, so y is equal t, this is also the same t, so I can write my x is sine y. Okay, and if you remember, okay, if this is y, this is x. Okay, if I try to draw the y equals sine x, I will get this curve, right? So how about if I draw x equals sine y? It will be like this. Okay, this is y equal 1, and this is x equal 1. Okay, and this is exactly pi over 2 here. So this is how you draw the red line, the x equals sine y. Okay, another examples. I have vector functions t okay. So how about this curve? How to sketch? So first, maybe I will write this x is t squared, y is t with the power of 4, z is with the power of 6. Okay, again, if we consider t equals 0, x is 0, y is 0, z is 0. Okay. But let's just observe x here. Okay. X is t squared. And all of these three parametric equation, it has element of t, right? To be precise, it's element of t squared. Okay? So I can say y is actually, right, or I can write y is x squared, and z is actually this. X cubed, right? So if I draw so in xy plane, okay, in xy plane, I have the x squared. So this is y and xy plane. Let me write this as xy plane. So I will have that. Okay. And then in xz, I will also have the cube, but it will be more steep. Let me just wait. Yeah, like that. Okay. And the questions is, how about the yz? So let's just look for the equation for yz. So if I have y is x squared and x is square root of y, then z will be square root of y cube, or I will write this y with the power of 3 over 2. So 3 over 2 will be around here. Yeah, wait, it's not really, yeah, more or less we have this in yz plane, xz plane. So all of this blue line, that is the shadow of our projections. Okay, that is a shadow from our vector functions. So what the vector functions really is, let me show you when t is equal another number. For example, 1 is 1, 1, 1, right? If 2, so x will be 4, y will be 16, and z will be 64. Okay. And you can also try to calculate the other number, 3, 4, 5, etc. So again, it's similar to our previous examples. We need to if you need to draw the factors, you need to draw the factor, but because the factors will be complicated here, this blue line, the shadow line, will help you to draw. So for example, t equals 0 is here, and when t equals 1, so, well, if you see here, it's 1, 1, and 1 here, so maybe it goes from here, and it's going up, but you cannot see it's going up. Yeah, I will draw like it has having a gap there. or maybe I will draw a little bit higher so that you can see that the gap here. Okay. This is t equal 1. When t equal 2, you see the x will be in the fourth and y will be maybe 16 here, and 64 is really high, so it will be going up and up and up here. But if you project this red line, this curve, the space curve, into each plane, it will be perfectly match the xz plane, yz plane, and xy plane. But yeah, it should be really high. Maybe it should be like this. Sorry, I will try to draw a little bit higher. It should be like this. Yeah, more or less like that. Okay. Wait. Yeah, more or less should be like that. So when you try to project this red line into each of the plane, it will be perfectly match the blue line, the shadow of the space curves. Okay, so that's actually just a basic introduction for the vector functions. So we will go deeper in the vector functions, and we will include all the calculus part. So the next part will be the calculus. So you will have the definition for limit, derivative, yeah, at least these two first, okay, for the next class. Okay, so that's it for this video recording. I hope you at least get the idea for the vector function and space curves, and see you in the next class.